Hello everyone, welcome to AOS-CX 10.11 update. I am Shobna, Technical Marketing Engineer, Aruba Campus Switching. In this session, we will know about DoDin APL Certification update. So this is the initial session on the certification. We do have other sessions posted in our channel. This session covers following: two-factor authentication remote only feature and unknown Unicast flood blocking. Let's jump into the session. Let's see the agenda of this session. We will talk about the abbreviations used in the project, overview of DoDin APL certification, in-depth understanding of two-factor authentication remote-only feature, and unknown Unicast flood blocking. Abbreviations: DoD, Department of Defense; DISA, Defense Information Systems Agency; APL, Approved Product List; UUFP, Unknown Unicast flood blocking; TE, Trust Anchor. Let's see the overview of DoDin APL certification. The Defense Information System Agency maintains the Department of Defense Information Network approved product list process on behalf of Department of Defense. This process provides a single consolidated list of products that have met cybersecurity and interoperation certification requirements. The DoDin APL is an accusation decision support tool for DoD organizations interested in procuring equipments to add to the DISN to support their mission. The US government and defense organizations will only procure products that compile with DoDin APL process for the Department of Defense networks. Hence, there is a need for getting our AOS-CX switches certified with the DoDin APL certification. So far, we have seen about DoDin APL certification. Let's understand the new enhancements added in 10.11 for upgrading this certification. The AOS-CX switches operate under stern adherence to international US government computer security standards in order to satisfy or exceed the demands and requirements of national agencies, organizations, and other publicly funded institutions. Most of our switches are DoDin APL certified from 10.6 release, but once a product is certified, the DoD components perform upgrades and maintenance for the life of the product to meet ongoing security requirements. Hence, these are updated to the existing certification. So these enhancements are mainly a host of tertiary security features required to ensure the security of our AOS-CX switches. So in this session, we'll see about two-factor authentication remote only and unknown Unicast flood blocking. Let's first look into two-factor authentication remote only feature. So before we look into the remote only feature, let's see the background about how the legacy two-factor authentication local user feature works. Two-factor authentication is a form of multi-factor authentication. Technically, it is in use anytime two authentication factors are required to gain access to a system or a service. Two-factor authentication local user feature is supported in AOS-CX switches for SSH connectivity from the initial release onwards. Let's see how it works. For accessing the SSH session of the switch, certificate and username and password are the two factors. Both authentication factors has to succeed to get access to the switch SSH. When user establishes an SSH connection to the switch, the two-factor authentication works as follows. The username in the X509 certificate is validated against the local user accounts on the switch. So it's mandatory to have that local user accounts configured in the switch. The user's X509 certificate is verified using the configure trust anchors or the root TA certificate of the X509 user certificate. So the TA certificate of that user certificate has to be installed as a TA profile in the switch. The username and password are validated against the local user accounts on the switch, or optionally we can have a AAA server like Radius or Tracax for additional security. But the AAA server is optional here. If you need additional security, we can have a AAA server, but can be done locally as well. So even though we specify the AAA server for username password validation additionally, still it's mandatory to have local user accounts in the switch. So the authorization is done based on the user group or level mapping. In brief, authentication and authorization are coupled. So when we are using the authentication source as local, the authorization also should be local. If we are using authentication source as AAA server, then the authorization source also should be the same AAA server. So this is how the two-factor authentication was working in our switches till now. So let's see what's enhancement added in this feature for DoDin APL certification. In this remote-only two-factor authentication was introduced in 10.11 and X509 certificate-based authentication is combined with radius authorization. So in situations where locally the user should not exist in the switch config for security deployments like financial or defense vertical, this is a must-have feature. This two-factor authentication works as follows. The certificate is validated against the configured TA profiles in the switch. If the certificate validation is successful, then the switch sends a radius authorized only request to the radius server. That too only RADSEC. As additional security, we support this feature only with RADSEC as the radius server. So the radius packets has to traverse via a TLS tunnel. And it will check the username found within the certificate. The username will be chosen from the common name or subject alternate user principal name. And only the username will be validated for authorization in the remote radius server. There won't be any password validation. So username and password is not required at the time of authentication. The username will be fetched from the user's certificate. So basically, we have decoupled the authentication and authorization. There is no need for having user credentials stored locally in the switch. It's only driven by the remote radius server. So let's see the workflow of how this remote only feature works. So first, the user present in any of the client machine provides a certificate using the SSH client software installed in that client machine for SSH access. Once the certificate is provided to the switch validates the certificate against the configured TA profiles. So only then the next step authorized only request is sent to the remote AAA server, that is a radius server. If the certificate validation fails, the client has been deemed authentication failure and SSH connection is denied. So once the certificate validation is successful, next a TLS tunnel will be created for sending the radius authorized only request to the remote radius server. This radius authorized only request is sent to the remote radius server, and that remote radius server will check the username present in the certificate and check if there is any user exists for that username and what is the authorization allowed for the user. So that response is sent as radius response to the switch back. So once the response is a success, then the switch will allow the user with SSH access and the user will be allowed to configure or execute commands based on the authorization supported for the user. So here is a brief comparison of the features for easy understanding. So first comes the certificate authentication. In both the features, it's handled locally. Certificate is validated against the locally configured TA profiles. Next, the username in the certificate undergoes local authentication, local user feature, whereas in remote only feature, it's sent along with authorized only option to the radius server. The username and password are validated locally or additionally AAA server in local user feature. But here the username and password are not required. Only the username in the certificate is checked for radius authorized only request. Here the authorization is coupled with the local authentication or the remote AAA server. Here the authorization is fully radius only. There is no local authorization here. Here are the major benefits of two-factor authentication remote only feature. First, increased security. Provides stronger protection against unauthorized access to user networks. Its purpose is to make harder for cyber attacks and reduce fraud risk. And it reduces the impact of password breaches. By implementing this feature, the security of traditional username and password login is supplemented by an additional layer of protection with X509 certificates. Next, it addresses compliance regulations. Deploying two-factor authentication can be a key requirement when comes to compiling with the certain industry regulations like our DoDin APL certification. Next is improved usability. It is easy to implement, less admin intervention, and lowers help desk and security management cost. Overall, it meets our Aruba goal of zero trust security. Let's see the configurations required for this feature. First, SSH certificate as authorized key. So this CLI enables SSH enforcement that the username must be present in the certificate that is being used for authorization. This configuration alters how certificate-based authentication maps to a user account. So when this is enabled, SSH will not require user association with an authorized key and instead enforces that the username used to log in is present within the certificate. The SSH server will check for the username in the certificate's common name or the subject alternate user principal name for a match. Next comes the SSH two-factor authentication authorization radius CLI. This enables the selected SSH two-factor authentication method. First, the X509 certificate is presented by the switches authenticated. So when the authorization radius parameter is specified, instead of prompting for a password, the SSH checks only for authorization with the remote radius server. The local user is not required here. Next CLI is AAA authorization radius SSH and then the radius server group. This enables radius authorized only for use with two-factor authentication. So by default, radius authenticates and authorizes a client that is configured for AAA based access. This command causes the radius server instance to be used only for authorization, not for authentication. The authorization requests are sent over TLS and therefore radius authorized only requires a RADSEC as a radius server. So a RADSEC server has to be configured in a radius server group and that group has to be assigned in the CLI. So let's see the show command. So once we have configured the authentication method as two-factor, we can use the show SSH authentication method show command. This is a legacy show command here. Only the SSH two-factor authentication and SSH certificate as authorized key are the two show options added newly. So it displays the method of two-factor authentication, whether it is local user or remote only, and whether SSH certificate as authorized key feature has been enabled. So once authentication is completed, to view the authorization, we need to use the show AAA authorization show command. So it will display which is the authorization channel used for SSH. Show user authorization will display as user authorization through radius and authorization for SSH channel, and it will mention the radius server group that will be used for the SSH authorization. Next comes the debugging and troubleshooting. If we find any issues with respect to this two-factor authentication, we can use the below debugging. Like to view the events, we can use show events minus SSH underscore server. So it clearly explains about the events. So here there will be event for failure. So like the particular user logged in from this IP address for SSH has failed. And we can use the diag dump or debugging to identify the exact reason for the failure. Next debug available is debug SSH utils all. So this is the debug specific for the SSH daemon. So here we can use the show debug buffer and identify the debug log specific for the SSH daemon. So here also it will display the reason for the failure. So one of the failure reason here is the certificate was not validated. So it will mention like the certificate cannot be validated by the TA profile configured in the switch. So such errors can be easily shown in the debug output. So if you need the full details of how the SSH two-factor authentication remote-only feature works, you can use the diagdump AAA basic as a diagnostic command. So this diagnostic output will clearly show us the full authentication workflow. For example, here, the first phase is certificate has been validated. The next is there is authorized only request has been triggered for the user. So once that has been successful, the session is open for a user. So here we can clearly see the exact workflow of how this SSH two-factor authentication remote-only feature works. So let's see the best practices. So it's mandatory to use RADSEC server as radius server. We do not support the traditional UDP for this remote-only feature. And the radius server should support authorized only service type like ClearPass and free radius and NPS are commonly used radius servers. They support this authorized only request because we are particularly validating only the authorization for the user. We are not checking the authentication username and password in the radius server. And then the SSH client application should be configured to get username from the X509 certificate. Only few of the applications currently support X509 certificate authentication in SSH client software like Secure CRT, Pragma Fortis, SSH client suite, and other Linux-based third-party clients currently support X509 certificate authentication. So that SSH client application should be able to get the username from the X509 certificate. With respect to RATSEC servers, these are currently the supported RATSEC servers. So ClearPass, FreeRadius. If the Radius server does not support RATSEC, we can also use a RATSEC proxy in between the switch and then the Radius server. So that can also act as a Radius server and proxy all the requests on behalf of the actual Radius server. Let's see the parity analysis. This two-factor authentication feature, both local user and remote user, is available in our AOS-CX switches. Let's see whether the remote only feature, how it's been compared with the other switches. First comes our own AOS boxes. So here the support is partial only. Why the reason of partial support is the way two-factor authentication works in these switches is different. So here the two factors are, one factor is public key and password. The means like factor one is public key and factor two is password. The other combination is factor one as certificate and factor two as password. So here there are two types of two-factor authentications options available. Apart from that, there is no decoupling of authentication and authorization. So both authentication and authorization sources should be the same for this AOS box. Hence, the reason it's not exact replica of how our CX switches with remote only feature is implemented. Here, the two-factor authentication is supported, but it has been designed differently. Similarly, even in S3C switches, it's a partial support where there is a two-factor authentication which are available, but not exact replica of how our AOS-CX switches works. Here, the SSH two-factor authentication uses the password and public key as the two-factor, and authentication also it's either over the local or the remote. There is no decoupling of authentication and authorization. And Cisco switches was not supporting the exact two-factor authentication for the SSH users. That's the reason we have mentioned it as not supported. Let's see a demo of this feature. So for this demo, I'll be using the below topology. I'll be having a user present in the Windows 10 client machine. This user will be using Secure CRT as a SSH client software. So this user certificate has been signed by OpenSSL CA server. The CA server is OpenSSL here, and the client, that means the user's client machine is Windows 10, and the user will be using the SSH client software as Secure CRT. And for AOS-CX switch, I'll be using a 6300. And as a RATSEC server, I'll be using our own ClearPass as a RATSEC server. So the user will try to SSH the switch, and there will be a radius authorized only request sent via over TLS tunnel to the ClearPass RATSEC server. So for this demo, I'll be using two switches. The first switch is in 10.10 version that will be used to demonstrate two-factor authentication local user feature. And the other switch in 10.11 version for demonstrating two-factor authentication remote only feature. So I'll be demonstrating both the features to know the differences between them. First, we'll see two-factor authentication local feature. This is the configurations required for the SSH authentication via two-factor. So SSH two-factor authentication has to be enabled, and then locally the user one has to be executed with the authorized key, and then the locally the user has to exit. So if you check show user information, so we have created a user one and group admin, and then provided a password. So locally the user account exists, and there is a user's key being added locally in the switch, and then we have enabled SSH two-factor authentication. So let's see how it works. So it is fully only locally. I'm not using any remote AAA server here. So this is the management IP for the 10.10 versions, which let me connect to it. So it asks both username and then password. So here the authentication is successful. So this is a secure CRT tool that will be using the SSH X509 certificate. So for configuring this tool, we have these options and then global options. Here, when we go to SSH2, there is an option to use certificate for the SSH2 authentication. Here you have to select the certificate. If you see here certificate to use locally, that certificate has to exist in the client machine from where the SSH secure software is being installed. So this certificate has been selected, and then as discussed, we have to identify the option to get username from the certificate. So either it can be common name or the principal name. Here we are selecting the username to be fetched from the common name field in the certificate. And next is the public key. So if you go for this user certificate, we can extract the public key from the tools itself. So there is an option tools export public key from the certificate. So here there will be option to export the certificate's public key. So that public key we can store in the switch using the users SSH1 authorized key. So this SSH users authorized key is fetched from this application's public key. So here it will select the certificate we are using and then give OK. So here it will display the public key from the certificate. So this public key we can copy and then we can use the CLI in the switch user1 authorized key and then configure the public key of that user locally in the switch. So locally we need to configure the local user account and then the user's public key in the switch for this SSH two-factor authentication. So let's see how two-factor authentication remote only feature works. So I will log into the switch in 10.11 version. So here I have enabled the two-factor authentication as remote only. So let's see the CLIs required for it. So first is the radius server configuration. So that will be used to configure the radius server as the RADSEX server and via which management via TLS is the option for the RADSEX server. So next is the group configuration for the RADSEX server. So we have to create a group and then assign that RADSEX server in this group. So next for authorization, we need to enable AAA authorization radius SSH group and which is the group we have configured here. And then to have the certificate as authorized key, we have to enable the CLI SSH certificate as authorized key. And then enable the two-factor authentication remote only feature using SSH two-factor authentication authorization radius. So these are the CLIs required. So apart from that, for certificate validation in both the versions 10.10 and 10.11 version, we need to install the root TA profile of the user certificate. If you see here, the user certificate installed for this user is, so this is a user one, this is a certificate and is issued by the CA, new Ubuntu CA. So this CA certificate has to be installed both in 10.10 and 10.11 version for certificate validation. If you see here, show crypto, PKI, TA profile. I have installed this TA profile. This is the TA profile that will be signing the user certificate of the SSH client. If you see here, it is the common name with new Ubuntu CA Shobana. So this is the CA server that will be signing the user's X509 certificate. Hence, the certificate's TA profile has to be present in the switch. So I have configured the certificate even in this 10.11 version for certificate validation. So this certificate is present in the switch TA profile list. So once this configuration is made, we have to make sure the radius server is available. If we see show radius server detail, we can check the RADSEC server has been available and it is present in the server group TLS. And then the TLS connection status is established. Make sure the RADSEC server is reachable before doing the SSH two-factor authentication. So once this configuration is present, we'll move to the clear path for the RADSEC radius authorized only configuration. So in the clear path, we need to configure first enforcement profile for the SSH access. So I have created an enforcement profile with user admin role as user1 group. So this user1 group has to be locally present in the switch with the allowed list of commands that the user is allowed to execute. So I have created a user1 group in the switch and then assigned that user using the Aruba admin role VSA. So if you check the show run, so this is the user group configuration, user group, user1 group, and then I have permitted only the show commands. So all the show commands will be permitted for the user, and the user will be denied with other commands. So the enforcement profile is the first step to be configured for the user. So this user will be mapped to this user1 group. Next will be the policy to do the mapping. And the main important part is the services. So there should be a service that will be performing only the radius authorized only because it will not be doing any authentication. So the service type is radius authorization only. So this service type will match the following rule. The radius IETF attribute service type only when then it equals authorized only. So this service will be selected. So this service is specifically for authorization. So there won't be any authentication happening in this service. In this service, I have called the enforcement profile that I have configured for the user. So I'm just making a basic condition like if it is any day, the user will be allowed access based on the enforcement profile. So let's perform the two-factor authentication. So I'm connecting the switch in 10.11 version. I will disconnect this. So if you could see here, there was no username password from the username will be taken from the user's X509 certificate common name or the subject alternate user principal name field, and the password is not required for this switcher. So you were able to seamlessly do SSH authentication to switch with the X509 certificate validation. And when we try to execute any configurations, so cannot execute because user is allowed to execute only the show commands. So the show commands the user will be able to execute. So that's how this two-factor authentication remote-only feature works. So we can check in the clear path whether the user authorization is completed. So the user authorization is completed here and the user has been accepted with the role as user1 groups. Hence, the user was not able to execute any configuration commands. He was able to execute only the show commands. Hence, we have come to the end of this two-factor authentication remote-only demo. So you can use this feature for more additional security on your switches. So here comes our next feature, unknown unicast flood blocking. The unknown unicast flood blocking UUFP controls flooding of L2 unknown unicast packets. The L2 switches by default will flood L2 packets to all interfaces within a VLAN if the L2 destination MAC does not appear in the L2 forwarding table. So the UUFB is applied at L2 ports, both access and trunk ports, to prevent flooding of L2 packets to other L2 access and trunk ports within the same VLAN. So let's see the use case. So the access layer switches use the content addressable table to direct the traffic to specific ports based on the VLAN number and then the destination MAC address of that frame. So when a switch has an ARP entry for destination host and it forwards to the access layer switch, and if there is no entry corresponding to the frame's destination MAC in the incoming VLAN, the packet will be sent to all forwarded ports within the respective VLAN. We see here, if a workstation sends any unknown unicast packets, first destination MAC will be checked. If the destination MAC is not present in the switch, so all ports within the VLAN will be receiving that unknown unicast packets. So it will create flooding. So this large amount of flooding traffic can saturate the low bandwidth links, causing network performance issues or complete connectivity outage to the connected devices. The unknown unicast flooding has been a troublesome problem in networks that are asymmetric switching and default timers. To mitigate the risk of connectivity outage, the unknown unicast flood blocking feature must be implemented on all access layer switches. The UUFB feature will block unknown unicast flooding traffic and only permit egress traffic with a MAC address that are known to exist on the port. Let's see the guidelines. So this feature is supported on all platforms except 6100 and 6000 and not advisable for environments relying on unicast flooding like Unicast, Wake Online. So even though this feature greatly helps us from traffic flooding, there are other applications that rely on unknown unicast packet flow. So such kind of applications, it is not advisable to configure this unknown unicast flood blocking feature. And it is not supported in following interfaces like LAC, ISL, routed ports, VTEPs, tunnel interfaces, and VLAN interfaces. It's only supported in physical L2 ports. So let's see the configuration and show command. To configure UUFB, we have to go to the interface and then enable UUFB. So to view the configuration, you have to use the show run interface and then the interface number. It will display the interface configuration along with UUFB if it is configured. Next comes the debugging and troubleshooting. So even though this feature is over the physical ports, it works based on the VLAN enablement for the port. So we need to enable debug VLAN ASIC to identify any failures with respect to this feature. And to view the feature enablement, we can use the diagnostic commands, diagnostic datum L2 VLAN basic. So here it will display the port level whether UUFB is enabled. So this diagnostic dump can be checked if in case there is an issue in the feature configuration. Next, the parity analysis. So this feature, whether it is supported in our other third-party switches. So first comes our own product AOS. So AOS box does not support this full block of the unknown unicast packets. Next is H3C. The H3C has partial support using rate limiting. So instead of completely blocking the packets, the H3C has support for suppression based on the rate. So here is the CLI interface level. You can use Unicast suppression kbps and we can mention how much kbps of the packets can be suppressed. So next is Cisco. Cisco does the exact replica of how our AOS-CX boxes be implemented. Here we can go to the interface context and then use switch port block unicast CLI. So it will completely block the unknown unicast flooding. So let's see this feature along with a demo. So for this unknown unicast flood blocking feature, I'll be using 3 ports. So all the 3 ports are in default configuration in the same VLAN. The port 1 will be sending unknown unicast packets to the port 2 and 3. So let's check the traffic flow. So if you see here, the port 1 is sending 20% rate to port 2 and port 3, and all the ports are receiving this unknown unicast packet if they are in the same VLAN. So let's try to enable this feature in one of the ports. So I will enable this feature in the second port. So once the feature is enabled, there will be event generated. So the event is generated, that feature is enabled. So let's see the feature. Now the unknown unicast packets are completely blocked in the second port, but it's not affecting the third port. So only the port in which this configuration is made, it will be impacted by this configuration change. Let's disable this feature. So this feature will be applied on the fly. I'm disabling it. So there will be corresponding event generated for the disablement as well. Let's see, the feature has been disabled. Let's see the traffic. So the traffic has resumed. If you could see here on the fly, the configuration can be applied and then also disabled, and it will impact only the port in which the configuration is made. It will not impact the other ports. Try to implement this feature and prevent your network from unknown unicast flooding. Thanks everyone for watching this recording. If you have any further queries, do post your queries in our adherence community.